my name is Rafan Azhar, and I'll be presenting a final project on predicting bike rental demand using Bayesian Inference on behalf of my team. My team members are Arunatri and Yadav Ranganathan. In this project, we incorporate weather and seasonality factors to predict bike rental demand. Let's begin by looking at our research question. Our research question is, how can Bayesian inference be used to predict hourly bike rental demand, accounting for seasonality and weather conditions? This is important because understanding rental demand helps bike sharing systems optimize availability and reduce operational costs. Bayesian inference allows us to combine prior knowledge with observed data, accounting for uncertainty to make more reliable predictions. Now, let's move on to the dataset we use for this analysis. We are using the bike sharing dataset from the UCI Machine Learning Repository, focusing on the year 2012. The key variables include bike rental counts, temperature, humidity, wind speed, season, hour of the day, and weekday. These help us capture both weather and time-based influences on bike rentals. Next, let's quickly look at some patterns in the data. To understand bike rental patterns, we created 3 visualizations. The histogram shows that most rentals occur in lower ranges. The middle time series graph shows how bike rentals vary across weekdays with some peaks on specific days. The rightmost graph highlights how rentals increase with temperature, peaking during the warm months. This analysis gives us a strong basis for selecting predictors in our model. Now, let's delve deeper into other factors affecting bike rentals. In addition to the patterns we observe for weekday and temperature, we also explored other important factors that influence bike rentals. For example, we found that bike rentals tend to decrease when humidity is high, likely because people are less inclined to rent bikes in muggy weather. Similarly, higher wind speed results in fewer rentals, which makes sense since biking in strong winds is more physically demanding. We also noticed clear peaks in bike rentals during commuting hours around 8 a.m. and 6 p.m., when many people are using bikes to travel to and from work. These insights about how environmental conditions and human activity influence rentals are critical for our model as they help us account for the dynamics of bike rental behavior. Next, we'll look at how these variables interact with each other. Here we have the correlation matrix and summary statistics. The correlation matrix shows positive relationships such as between temperature and rentals, and negative ones like wind speed and rentals. The summary statistics gives us key insights into the distribution of our main variables, including the mean and standard deviation, helping us understand the range and variability in our data. These relationships and statistics guide how we structure our model. Now, let's move on to the model we selected. We selected a hierarchical Bayesian Poisson regression model to predict hourly bike rentals. In this model, the number of bike rentals, yi, is assumed to follow a Poisson distribution with rate lambda I. The rate parameter lambda I is modeled using a gamma distribution, which allows for variability in the rental rate across different conditions. The mean rate mu I is a linear combination of factors such as temperature, season, hour, and other independent features. We chose this particular model because it offers the flexibility to capture variability in bike rentals due to weather conditions and time of day. The Poisson gamma structure helps us model uncertainty in rental rates, allowing for fluctuations caused by unpredictable factors like changing weather or human behavior. Moreover, the hierarchical structure enables us to account for the differences across groups such as hours or seasons, and this helps us make better predictions for times or conditions where we have less data. The Bayesian approach provides a way to incorporate prior knowledge and handle uncertainty throughout the model, making our predictions more robust and reliable, especially when dealing with noisy or incomplete data. To conclude, we used a hierarchical Bayesian Poisson regression model to predict bike rental demand. This approach allows us to factor in both weather conditions and human activity, improving decision making for bike sharing system. Thank you for watching this presentation.